This is Srikanth, working as assistant professor in electrical department. So now I want to discuss some topics. So basics topics on our electrical circuits. So in electrical circuits, we have DC as well as AC. So on DC, we have some topics as well as AC also we have some topics. I will discuss in this video. Okay, please watch up to end. So every minute, every second is very, very important in this video. If you watch up to end, you will get some different knowledge on your electrical circuits. Here I have some topics, some definitions like Ohm's law and some elements. We have different elements and independent dependent sources and voltage and current relationship for passive elements like RLC elements. And same thing we have like a AC. For AC, so I will get like AC wave, sine wave and their properties and phase differences and different periodic waves, as well as so what is impedance, what is admittance and power in AC circuits. So we have the active power, reactive power and apparent power. So we'll discuss all those topics in this video. Okay guys, now before moving to our topic, I have one more small topic, that is open circuit, short circuit. So open circuit as well as short circuit. So what is the open circuit? So if you observe clearly, open circuit, suppose I have some supply here. Okay, some supply here. It's now open circuit. Then we have voltage as well as current. So what is the voltage value? In open circuit, the value of voltage is maximum. So how much voltage we have? So that much voltage will get in this open part, open terminal. Coming to current, open circuit current is 0. So there is no closed path. For open circuit, the current is 0. So why means if you have the closed circuit, then only the current flow is there. Some load, then only we have some current flow. Some charged particles need to flow. Okay, so open circuit, short circuit. So open circuit, the current is 0. For closed circuit, we have some current value. Depending upon your load, the value will be changed. Okay, and same thing we have like a open circuit as well as short circuit. This is like open circuit and closed circuit, and we have one more short circuit also. For open circuit, current is 0. For short circuit, voltage is 0. And here open circuit voltage is maximum, here current is maximum. So just remember these two things. We'll get different problems on this open circuit and short circuit. And coming to, we have like a voltage, current and power. So voltage, current and power. So not VCP. Okay. So like VIP. So voltage we can represent with a V and current represent with the I and power represent with P. So VIP, voltage, current and power. Okay. So in general, voltage in your home we will get like 230 volts. So for single phase at even home, so everyone have like 230 to like 240 voltage. Okay, and for controller, for any controller we have 0 to 12 volts. For any controller, like in your home you have the batteries, so batteries has like 1.5 volts. Okay, so in different places we have different controllers. For every controller we have 0 to 12 volts, maximum 12 volts for DC. For AC, for single phase, we have the AC 230 volts, and single phase DC also we have, that is 220 volts. Okay, and coming to power, we know that voltage into current. Okay, voltage into current, we know that power value, but what is the current value here in home as well as controller? So the current value is depending upon a load. So depending upon different load, the current value will be changed. If you observe like main difference between AC and DC, we have DC positive and negative. Coming to AC, we have phase and neutral. For DC, we have positive, negative. For AC, we have phase and neutral. And for DC, we have only one direction. So negative to positive, we have only one direction. Coming to AC, we have alternative at both direction. So in your home, suppose your charger is 2-pin plate, you can use any manner. So phase and neutral or phase. Coming to DC, you need to use only positive or negative. So we can't use like reverse. We can't get any output value from DC. Okay, and same thing here we have like voltage 220 for DC, 230 for AC, and for AC we have 3-phase voltage also, that is 415 volts. In industry you can use like 3-phase. So for 3-phase 415 volts we have, and DC the frequency is 0. For DC the frequency is 0. Coming to AC, we have the frequency 50 Hz in India, and in different countries we have like 60 Hz also. Okay, in India we have the 50 Hz. And if you observe the waveform for DC and AC, for DC it's a straight line. Coming to AC, it's alternative. So we have the positive peak as well as negative peaks. It's an alternative supply. Okay, so this is small difference between AC and DC. And coming to definitions, so we have like current. So suppose here I have a conductor. So conductor has free electrons. The flow of electrons in a conductor is nothing but your current. Simple. So I have one conductor. Conductor has free electrons. So the electrons flowing one place to another place is nothing but your current. And the equation for the current is charge by time. Charge by time. So the electrons depending upon time, flowing time. So charge by time is nothing but your current. And units is amperes. And now moving to voltage, the potential difference between 2 points. You can write like that also, no problem. The potential difference between 2 points is nothing but your voltage. So how much work is done by your charge. So in a conductor, I have like free electrons. Okay, so the electrons flow is your current, the charge by time, and how much work done from this place to here. So this potential difference between 2 points, nothing but your voltage. Okay, and units is volts. Coming to power, so before moving to power we have the electrons. So electrons, energy. So electrical energy, you say like electrical energy. So electrical energy is nothing but charge into volts. So charge into volts. So where we have the potential difference. So in conductor we have the electrons. So energy is nothing but your how much work done. So total output is nothing but your energy of your electrons. Okay, so that is energy. Electrical energy is nothing but depending upon charge and potential difference. So if you go for the power, you will get the answer. So power is nothing but we have like V into I. Am I right? Voltage into current. So this voltage is potential difference, and this current is nothing but your charge. Nothing but electrical energy. So coming to power, you can say like the work done with respect to time. So work done, how much work done with respect to time. Otherwise, suppose V into I. Am I right? So V is W by charge and I is charge by time. So we'll get like W by D. So work done, how much work done in seconds or in different time. So that is your power, and power units is watts. So these are small definitions. So we know that in intermediate also. Coming to Ohm's law, and the Ohm's law at constant temperature. So why is constant temperature? Means In a conductor, the free electrons, so flowing one place to another place, that is the flow of electrons is directly proportional to potential difference. So this is my conductor. Some electron is flowing in this conductor, that is proportional to your potential difference. So I is directly proportional to V. This is your Ohm's law. Okay, and with the formula for that Ohm's law is V equal to I into R. Here R is your resistance. So why this resistance means, if suppose the R value will be changed, automatically your voltage value will change, not depending upon your current. So in general, I is directly proportional to V. So the constant, which constant do we have, which value we have, that value is constant. So your R resistor value will change in different temperature. Okay, if you have the resistor, this resistor value will be changed on different temperature. So depending upon different tolerance. So the R value is constant. So a particular temperature. So constant temperature, the flow of electrons is directly proportional to your voltage. And we have some limitation for this Ohm's law. So only applicable for silver and copper type of conductors. Okay, not transistor, diodes, IGBTs. Clear? And you can observe this waveform also. Ohmic conductor means both are proportional to each other, voltage and current. So not ohmic means not proportional. And coming to formulas, so you can say this is like a Ohm's triangle. If suppose I want V value, V equal to I into R. So I into R. Suppose I want I value, that is V by R. Suppose I want R value, V by I. So like, if you remember like this also, using Ohm's triangle. And same thing we have, like if you know I value, P value, R value, I can find out like V value in different manner. So for V, I into R. For V, P by I. For V, root of P into R. So for voltage, we have three different formulas. In exam, he given like R value and I value. You need to find out the V value. If suppose he given like P value and R value, I need to find out the V value. Same thing we have like I and power and resistor. We have different values also. And for each value, we have different formulas. For P, suppose I need to find out the power, but I have voltage and resistor. I have the voltage value and resistor value. I need to find out the power. So V square by R. And here I have like a P value and R value, and find out the I value, that is root of P by R. Okay. So these are small formulas which you know already. Okay. Now coming to next, elements. So we have network elements, different elements we have. So active elements, passive elements. Mainly we have active and passive elements. So active element, passive elements. And we have linear, non-linear, unilateral, bilateral, time variant, time invariant, and lumped distributed. So these are lumped distributed elements are used to transmission line side. And time variant, time invariant, those also depending upon your Ohm's law. And coming to unilateral, bilateral, where we have like current direction. So suppose this is a diode. So here we have only one current direction. So there is no reverse. So this is like unidirection, and bidirection means for resistor. For resistor, the current direction both side. So unilateral, bilateral means depending upon your current direction. Suppose current direction both side means that is a unilateral. Suppose the current direction only one side means that is bilateral. And coming to linear, non-linear, so this is also Ohm's law, depending upon Ohm's law. Suppose your elements, which elements we have, depending upon your Ohm's law. So which satisfy the Ohm's law, that those are the linear elements, not satisfy the Ohm's law, that is non-linear elements. So here also we have the passive elements, RLC, and here non-linear elements, diode, transistor, capacitor, like electronic devices. Coming to passive elements, those are resistor, inductor, and capacitor. So passive elements means resistor, inductor, capacitor. So three are passive elements. We'll discuss about three also. So coming to active elements, we have dependent source and independent source. So in that names it is there. So dependent means is depending upon someone. Independent means not depending upon any other. So dependent and independent. Again, dependent source we have 4 types and independent source also 4 types. So independent source, ideal and practical. Ideal voltage source and ideal current source. Practical voltage source and practical current source. Ideal and practical. So what is the ideal and practical? So ideal means, so this is on source, suppose voltage source. This voltage source not having any internal resistance. So practical source means same voltage source having some internal resistance. So which source having internal resistance, that is practical sources, current source or voltage source. And which source not having the internal resistance means that is ideal source, voltage source as well as current source. For voltage source means we have the positive negative signs. For DC and AC we have like sine wave, and coming to current source like direction. So direction. So practical means we have some internal resistance for current source, voltage source also internal resistance. For current source, the practical current source, for practical current source I have internal resistance means that is parallel with that source. So current source parallel with internal resistance, voltage source series with that internal resistance. Coming to dependent sources, we have again 4. So here voltage source, current source, current source. So voltage source we have 2, current source we have 2. So this voltage source depending upon another voltage, same voltage source depending upon another current source. So current dependent voltage source, voltage dependent voltage source. So voltage source, this is the voltage source depending upon voltage and depending upon current. So we have 2 here. And if suppose this is a current source depending upon voltage, depending upon current. So again 2. So 2 plus 2 have the 4 sources. We'll check it now. So for ideal and practical, so here these 2 are ideal sources. So ideal voltage source and ideal current source, ideal voltage source and so practical voltage source and practical current source. For here I have the internal resistance something, and here I have the internal resistance something. Observe both sources. So practical sources, voltage source series with that internal resistance, current source series with so parallel with that internal resistance. Coming to dependent sources, so here we have the diamond shape. So where we have the diamond shape sources means those are the dependent sources. So we have the plus minus means it's a voltage source. If you have the direction means it's a current source. So voltage source and current source. This voltage source depending upon some another voltage means this is voltage dependent voltage source. So this is a voltage source but depending upon this voltage. And same in this current source. So this is a current source depending upon voltage. So voltage control current source. Coming to here, I have the voltage source depending upon current. So this is current control voltage source, and here current source depending upon current. So current control current source. So just observe clearly and get the answer. Coming to passive elements, with the resistor, inductor and capacitor. For resistor we have the formula rho L by A. So don't forget that formulas. Rho L by A are equal to rho L by A, and here this is the rho is resistivity and L is length, and rho L by A, L is length and A is area. And coming to symbol, this is a symbol for resistance, and in practical you can see this type of resistors, and the units for resistor is ohms. And we have color code also. For any practical resistor we have colors. So for each color we have different values. So here brown, black, brown, red, orange, yellow, green, blue as well as violet and grey is there, and white also we have, and last gold and silver. These 2 are for tolerance. And coming to values, for black 1, brown, so black 0, brown 1, red 3. So I have different value for each color. And multiplier also. Why this multiplier means, so I have one resistor here. If you observe this resistor, for example, here gold color, so it's a tolerance, and before gold color it is multiplier. Before gold color, so this is a tolerance before it's a multiplier, and remaining 2 are values. So This is a yellow. Suppose yellow is 4, and this is a violet is 7. Last orange multiplier. So this is a multiplier value. So orange multiplier is 3. So 10 power 3. So this is the value for this resistor. And tolerance, gold tolerance is 5%. So tolerance 5%. Okay. If suppose I have the 3 colors, so here we have 1, 2, 3 colors. Suppose 4 colors. 4 color also first 3. So 1. So here some color is there. So 1, 2, 3. 3 are values, and this is a tolerance. We will check it now. See here. So 1, 2, 3. 3 are values. Next onwards we have tolerance. So here also 1, 2, 3 are values. Next, this is like a multiplier, and this is a tolerance. Okay, this is about color coding. And coming to current relationship for resistor, R equal to V by I, and V equal to I into R, I equal to V by R. From Ohm's law we have these values, so no need to worry about that. And coming to inductor, for inductor we have V L di by dt, V equal to L di by dt, and I equal to 1 by L integral V dt. Coming to inductor, for inductor, suppose exam he given like a number of terms, area and length and mu value, then we need to find out the inductance, means you need to use this formula. So for inductance, this is a formula for inductance. And coming to energy stored in an inductance is 1 by 2 Li square. So in exam he given like some energy value and some inductor value. Just find out the current flow. So use this formula and find out the current flow value. Okay. And suppose you given like timings, so 0 to some 2 seconds, then find out the current flow. Use this formula. Okay. So which formula useful for different places? Use that formula and get the answer. And coming to capacitor also, for C, for I equal to C dV by dt, and V equal to 1 by C integral I dt. And coming to capacitance is A by D. So D is distance between two plates, and A is area, and this is the plates resistivity. And energy in capacitor is 1 by CV square. For inductor, 1 by 2 Li square. And these are the formula for capacitor, current and voltage formulas. And coming to alternating current. So when we have the alternative, means we have the positive as well as negative. For sine wave, if you observe the sine wave, we have peak value, and peak to peak value. So this is a peak value, and this is the peak to peak value. If you observe clearly, here we have the two waves. This is the voltage waveform, this is a current waveform. For current waveform, so peak to peak value, this is a peak to peak value, this is a peak value. And time period is, suppose the waveform started here, and again same axis where the waveform started again. So that is your time period. Same thing, we have the two peaks. Between two peaks we have the wavelength. Okay. And we have one more for AC, or the frequency. So for frequency, F equal to 1 by T, that is 1 by time period, that is your frequency value. So depending upon different timings, the frequency value will be changed. Okay guys, this is about some information on sine wave. Coming to sine wave, I will generate the sine wave, means between two poles. So two magnets, we have the one armature. If you rotate the armature using brushes, and so using brush we are rotating this armature, will get some energy, the energy in form of sine wave. So at different places, so at 0 we have the 0, and 45 I will get some value, and 90 I have the peak value, again 180 I have the 0 value, again 270 I have the peak value, again 0 I have the 0. So different places I have different values. So using that value we will get a sine wave. For this sine wave, this is the equation. If substitute the values at 45, means we will get the sine Vm value. So V of t, suppose V of t equal to at 90. At 90 means Vm sine theta equal to 90. Then we'll get like sine 90 is 1. So Vm value will get. So maximum peak, how much peak we have, will get that 90 place. Okay, and this total is depending upon speed of your rotation. So in between two poles, I have the armature. So depending on speed also and coil strength also. So here we have, you can see here, speed, strength and length. Depending upon 3 items, the sine wave value will be changed. And coming to periodic waves, we have different periodic waves we have. So sine wave, square wave, triangular wave and sawtooth and complex. So mixing up different periodic waves. So here coming to sine wave, so starting here and again starting here. So this is a time period. Coming to, for sine wave, we have half wave and we have full wave. Same thing, square half wave, square full wave, triangle full half wave, full wave, sawtooth half wave, full wave. If you observe the time periods, so for sine wave, starting here, this is a time period, and coming to half wave, starting here, again for this axis started here, and full wave started here, again started here. So this is a time period for this full wave. Suppose I have one wave like this, 1 and 2, 3 and 4. Okay, see, this is the half of the wave started here, then again started here. So this is a time period. So no need to worry about the remaining wave, which wave, square wave and triangle. No need to worry about that wave. So where the waveform started, again same sine wave started here. So this is a time period for this waveform. So time period depending upon the frequency. So we need to mention the which time period for which waveform. And coming to phase difference. So phase difference is one of the main point. So we have the 3 phases in your in industries. Industry we have the 3 phase value. So 3 phase is 415 volts. The 415 volts is phase to phase difference. Okay, and phase difference is depending upon the starting point. So this is a time axis. This is like a voltage, like amplitude axis. So here, suppose the voltage waveform and this is a current waveform. The voltage waveform started at 0, but current waveform started before itself. So before itself, the current waveform started. So this is a voltage waveform started at 0 point. Before itself, the waveform is started. Current waveform. And the time period, suppose here to here, how much the value we have, same here to here, the value same. So time period for both wave is same. Voltage as well as current waveform, the time period is same. But the phase difference, so starting points is different. So the difference is nothing but your phase difference. So starting point is different. So that difference, which difference we have, always peak. If you are compared to peak values, so this peak and this peak, what is different? The different is phase difference. Okay, and I want to write the equation for each waveform. For sine wave started 0, so we know like a Vm sin theta. But your current wave started before itself. So before itself means plus theta. So omega t plus some phase difference. So how much phase difference we need to mention here. So Vm sin omega t plus that phase difference value. If suppose my waveform started after here, my waveform started, then sin omega t minus pi. So minus value. So this is our small difference between phase differences, and you can observe here also. So before we have the plus, so plus, and after we have the minus, so minus. Okay, so this is about phase difference, phase and phase differences, and we have one more logic on phase and phase difference. So phase difference is there means we have the inductive and capacitive loads. Where you have the inductive load and capacitive load, there you have the phase difference. So for phase difference, for inductive load is lagging. So current is lagging. For capacitive load, voltage is lagging. So current is leading. For capacitive load, current is leading. For inductive load, current is lagging. Okay, and resistive load, it's a unity. So there is no like a phase difference between voltage waveform and current waveform. Okay, so for inductive load, current is lagging. Why means inductive store the energy in form of current. So if you when we are switch on the supply, some energy need to store in this inductor, then we'll get the output. So some time taken process. So that time taken process is lagging. And same thing, capacitor store the energy in form of voltage. So voltage needs to store, then start the output. So current started before itself. So current is leading. So here you can see the lagging power factor and leading power factor. For inductive, it's a lagging power factor. For capacitive, it's a leading power factor. And next one, we have average value. For each periodic wave, we have different periodic wave. So for each periodic wave, we need to find out the average value, RMS value, form factor, and peak factor. So for that, we have the formulas. You can use the formulas and you can get the values. For average, the formula is 1 by t integral 0 to t f of t dt. So at each place, I need to find out the values. So for that, the average value is, this is a formula for average in general, but I have a periodic view for different places. So we have the formula is 1 by t integral the time period. So this t is your time period. Suppose here to here the time is t. So this time period into integral same time period. So different timings. Same timing into f of t. So this waveform equation. Okay, this periodic wave equation is your f of t. And coming to RMS, root mean square. You can write directly also. Root mean square. So which mean we have. So this is your average value. This average value, root and square. That's it. So root mean square. So this mean root and square. So which average we have? So 1 by t integral 0 to 2 f of t dt. So that is square and root. If you add square and root, you will get the average. This is the logic to remember. But the RMS value is depending upon the heat losses. So we have the heat losses in AC. So I square R losses. Depending upon the I square R losses, we will get like RMS value. Why this RMS value means for alternative supply. So we have the AC alternative. Suppose in particular time I want to measure that alternative means. So if suppose I want to measure, this is my sine wave. At this point I want to measure the supply. Generally, when I check the supply at different timings. So then in your multimeter, we'll get like positive 230 to negative 230. So it's a varying, not like fixed value. DC means it's a fixed value. But AC means it's alternating. Alternating means we can't say like which timing the value is there. So for that, for each meter, so any meter, any measuring meter, we can see only RMS value, root mean square values. Okay, that RMS value using this formula you can find out. That is 1 by t, root of 1 by t, 0 to t, f of t whole square dt. And coming to form factor, peak factor. So these are small formulas. So form factor means which RMS value we have, that RMS value by average value. And peak factor means peak value by RMS value. And coming to sine wave. So for sine wave we have the value. So I will find out the first is sine wave. Not only the sine wave, full wave we have, half wave we have, and triangular we have, as well as a square wave also we have, sawtooth we have, complex also we have. So for any wave, very periodic wave, I need to find out average, RMS, form factor, and peak factor. So for any wave, only on one procedure. First, we need to write the equation. So this is a sine wave. So I have the equation V of t sin omega t. Okay, and then find out the time period. So for this sine wave, this is my time period. So started here, again started here. This is my time period. Okay, and we need to know the formulas. So this is average formula. This is the RMS formula. Then substitute. So for RMS, no need to worry about the time period. So no need to worry about time period. Coming to average, if suppose this is a positive peak and this is a negative peak. If you go to the average, you will get the 0. So just consider any one peak. So up to this or up to this, any one peak, positive peak or negative peak. Just consider any one peak and find out the up to that time period average value. So for this sine wave, if you observe here, the sine wave is the time period 1 by t, and here time period is 2 pi. So pi and 2 pi. Okay, and if you solve this equation, we'll get the average and RMS values. From the average and RMS, we'll get the form factor, P factor using our formulas. And same thing here also we have the time period. So which time period we need to follow here? So average and RMS, we have the same time period. Why means here positive peak is there, but there is no negative peak. But your time started here. So waveform started here, again time waveform started here. So your T is up to 2 pi. So 2 pi, 2 pi. Again substitute those values here and find out the values. And coming to 0 to sub pi, I have some peak value. So 0 to pi I have some peak value, and pi to 2 pi I have 0 value. Just observe clearly. So 0 to pi I have the value, pi to 2 pi I don't have any value. So same thing, you need to substitute the equation and get the answer. And coming to full wave, so full wave and half wave, maximum. So full wave and sine wave, which sine wave we have, main wave. So both values is same. The form factor, peak factor also same. So average value, RMS value for same for main sine wave and this full wave. Why means the time period is same. If you take the like a RMS value 2 pi also will get the same answer, and pi also will get the same answer. Coming to square wave, I said like first we need to write the equation. So what is the equation? So for sine wave, it's a straight line. There is no time dependent variant. It's a time independent variant. So we have the Vm value only. So which Vm we have, for average also same Vm and RMS also the same Vm. So form factor, peak factor is unity for square wave. Same thing, triangular. For triangular we need to go for the slope formula. So just observe guys. So for triangular wave, if you want to find out 0 to pi, suppose 2 pi. So if you want to find out 0 to pi, we will get the same answer. And suppose 0 to 2 pi also the same answer. Otherwise, we'll get pi by 2 also. 0 to pi by 2 also with the same answer. For complex networks, we can find out like half of the waveform. So how much average we have? Same average for this, same average for half also. And RMS also the same answer. So when we have a triangular or any other waveform, complex waveform, just go to like a half of the wave and get the time period. For the time period, just find out the average and RMS. And equation is for this slope, go for the slope formula and get the equation. And this is the one type of wave. So here you have the straight line and then square, again drop. So for this, I want to go for like 0, 1, 2. So up to 2 is enough for your time period. Otherwise, you can go 0 to 4 also will get the same answer. So 0 to 2 have the same answer, and 0 to 4 also with the same answer. So any time period, we can find out the values. But the conditions. So 0 to 1, I have some different time period. So I have the different equation. And 1 to 2, I have different equation. And 2 to 3 have the same, both are same. So 1 to 3 have the same equation. And 3 to 4 have different equation. So I need, so 0 to 1 and 1 to 3 and 3 to 4. If suppose my time period is suppose 0 to 2. Then 2 time periods. So 0 to 1, I have one time period, and 1 to 2, I have one time period, time equation. So 2 equation, using the 2 equation, different timings. Here I have the 3 timings. So 3 different places. Substitute those values and get the answer. Any type of wave. Just remember, you need to go for the time period. So which time you need to consider, and what is the equation, which time period, which equation. Okay. And so one more important topic, that is impedance and admittance. So before going to impedance admittance, we have small relation. So I want to find out the impedance values. Okay, I want to add those impedance values. I want to divide those impedance values. I want to multiply those impedance values. Means I require the polar to rectangular, polar values. So these are the formulas for rectangular, polar to rectangular. Okay, so in exam, he given only, so no need to use the calculus. If you use the calculus, we will get the answer. Okay, but he given like more than like 4 marks. Then we need to use step by step and get the answer. So if suppose I have the rectangular form, x plus or minus y. So z equal to r plus jx. Suppose r plus jx, real value and imaginary value. Then I want to find out the polar form. So z equal to r angle with 0. So angle with theta. So this is a formula. So we need to convert polar to rectangular, polar. So suppose I have like r and y value, then your small r equal to root of x square plus y square. So which r square plus xl square. R square plus x square. Okay. Theta is x by r. So using this z value, x and y, using this z value, x, r and. So why I am write r and y means when we have the resistor and inductor both are in series, we have the r and is a x, l. So your impedance z equal, impedance means z, admittance means it's reverse of your z, 1 by z. So the value is r plus j xl. So for this I am convert into polar form means root of r square plus xl square tan inverse xl by r. So this is the polar form formula. Suppose I know the polar form and convert into rectangular form means for this we have the formula r cos theta, r sin theta. Okay, so this is about the rectangular polar, polar to rectangular, and we have one more topic, dot conversion. So like a J conversion. For J conversion, so for 90 we have plus J, 270 we have minus J, when you have 0 we have plus J, and we have 180 means minus 1 value. So why this means, if suppose my value is 90, angle 90 with r means you can say like a 220 angle with 90. So then you can write directly. So 220 J. So angle is 90. So value is plus J. J 220 you can write. There is no real value. Real value is 0. We have only imaginary value. If suppose I have 220 angle is 0. So we don't have imaginary value. We have only real value. 220 plus J of 0. So I don't have any imaginary value. So if you know the J notations, so which place we have. So suppose my area is this is. So if suppose your angle is 45, then your real value and imaginary value both are plus. So real value plus and imaginary value also plus. If suppose my angle is in this between this, so my real value is minus, my imaginary value is plus. And coming to in this place, my imaginary values and real values both are minus. Coming to in this angle area, my imaginary value is minus, but real value is plus. Okay, about J notation. And coming to one more topic, that is inductive reactance and capacitive reactance. So reactance is one of the key role for impedance and admittance, Y and Z. So where the inductor, this units is Henry. Here we have the resistor, this units is ohms. So I need to add both values. This is the passive element, this is the passive element. I need to add both values. So it's can't possible. So I need to convert this inductor Henry values into your ohms. That is XL value. That XL value is 2 pi FL or omega L. Same thing capacitor also. For capacitor 1 by 2 pi FC, and you can say like 1 by omega C. So for capacitor capacitor and inductor, we have the reactance value, that is XL and XC. So XC for capacitor, XL for inductor. Then the units is ohms. Then you can add both values. So we add both values means when resistor and inductor both are in series. Suppose this is supply, some supply I have. So both are in series. Then the impedance value is R plus JXL. You can see here. And both are in resistor and capacitor. Both are in series means we have R minus JXC. And coming to 3 are in series. 3 are in series means we have R plus JXL minus XC. So these are like a rectangular form and this is your polar forms. Okay. And coming to impedance. Impedance is Z value. So impedance is Z value, that is R plus J XL or XC something, real value and imaginary value. And admittance is 1 by Z, that is your admittance value. And conductance. So suppose I have the resistor. For resistor, the inverse of that resistor value is conductance. And we have the XL value, reactance. Reactance inverse is your susceptance. So these are the values for impedance as well as admittance. For admittance is reverse of your impedance, conductance means reverse of your resistor, and susceptance means reverse of your reactance. And when you want to find out the admittance value is, so R, L, C both three are in series, then the value is G is your 1 by R, that means reverse of nothing but your reverse impedance. And here we have X, BC and BL, so 1 by XL minus 1 by XC, so reverse of your impedance. And coming to power, so for power we have mainly three things: active power and reactive power and apparent power. So reactive power, real power. So real power means which you are utilizing the supply, and reactive power means we are not utilizing the supply, and susceptible power means your complex power. Now the units for active power is kilowatts. So we know that kilowatts, when you are getting the bills, means in kilowatts only, in units. Okay, and reactive power means kilovolts ampere reactive. And I want to find out those values means using same triangular, which triangle we have. So here we can see the triangular active power, reactive power. This is the real value, this is the imaginary value, and this is your apparent power, so complex power. So these are the impedance triangle. So from this impedance triangle, I want to find out the power factor. So power factor is also one of the topic in your module. Now cos pi is your power factor, active power by apparent power. So P by your S is your cos pi. Okay, for cos pi we know that power factor. So depending upon the resistive inductive loads, the power factor is unity power factor for resistor, and lagging power factor for inductor, and leading power factor for capacitor. And here we have real power. Real power means VI cos pi, and reactive power is VI sin pi. So units are kilowatts per reactive power, and reactive power is kVAR. So this is about like some definition and some logic, some idea about those AC and DC circuits. Okay, in next video I will discuss some problems on this topics. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.